Swayam Prabha. Digital India. Educated India.
Hello. Last day we discussed the technology systems and its role to deliver mass housing in India. We have discussed that the conventional technology is unable to deliver housing for the mass in a quicker time. So, there are alternative options. Faster technologies are available which can deliver housing in a quicker time. And we also attempted to see its characteristics, typologies of the technology systems and what are the options for India. So, today we will see the examples and how it can be feasible for Indian system. Like before I go to the example and the case study to understand the applicability for the Indian condition, briefly touch upon the points which we discussed last day. Like firstly, we discussed that for conventional technology, conventional construction methods, the construction is fully on site, and due to on site activities for the construction, sometimes due to the weather effect or the extreme weather effect, the construction is not possible. For example, during rainy season, during extreme winter, the construction is not possible. So, as a result, the construction become delayed, and because of the delayed construction, the time escalation and the cost escalation is the obvious reason, and the cost escalation is there, then the affordability or the affordable housing within the cheaper cost will not be possible. So, how we can tackle this problem? Now, there are options, there are technologies which actually involves the lot of manufacturing of the building components off site, that is in the factory, or it is manufactured and in a suitable time it is transported from the factory and just assembled using either manual and the industrialized mode of assembling in the factory in the site. So, site based activities are minimized. So, as a result the time is minimized. So, this kind of technology which involves lot of activities in the factories and less activity in the site, it is called industrialized building system. Sometimes we call it as a modular construction, sometimes we call it as a prefabricated construction, but this is the viable option which other countries have also tried. Next, we discussed that there are three typologies, three types of the industrialized building system. One is box system, which is nothing but to conceptualizing a building in terms of various cubes of the box as a building units. Second, we discussed the panel system. Panels are the load bearing walls which takes the load of the upper floors. So, panels are very big, load bearing, and also there are component based linear system, frame system, which conceptualizes the load bearing members like say column and also beams as a individual component and as a prefabricated component. And we have discussed last day that for Indian context, apart from the box system and the panel system, the frame system is suitable because of the load condition, because of the high availability of the manual labor. All these factors are involved. So, component based frame construction and also some amount of in contextual basis the panel construction also can be thought of is possible. And then also we discussed that as a process of the industrialization, it has a specific stages. India is currently in the stages just before the closed system. So, closed system is nothing but where only selective few developers develop the package the building as a package and delivers it. No other contractors or manufacturers are allowed to monitor or allowed to alter the designs or the construction, where the open system is a system where many contractors, many developers, many manufacturers take part, and they it is more open to the various stakeholders. So, open system invites open economy, open and it discourages the monopoly, and closed system basically ensures the quality because it is driven by only one unit, one suppliers, but sometimes it encourages monopoly. So, these two are the obvious. Closed system comes first, then it follows the open system. So, Indian system right now there are various companies or various manufacturers who are basically manufacturing building component, and government also is trying to cope up with the trend and the need for the day. So, with this background today we will see that how industrialized building system for India can be applicable for mass housing. So, this picture we saw last day also, that in any typical modular construction schedule, this is the time saving because of the off-site construction activity. The site based construction activity is reduced, and the site based construction activity actually done at the construction at the plant. So, now we will see the case study how industrialized building system in India is available, how much it can be applicable. Now, before I show this example and the case study, let me tell you that that in government laboratories like say CBRI or BMTPC or HUTCO, lot of experiments were there. They have developed, and Hindustan Prefab Limited, they have developed very innovative building components and very building materials as such, and those are tested also, and those worked very nicely in some of the context. But here the examples we have taken, it will show that how in a mass scale, in a thousands of unit can be developed, generated using the building components in the Indian context. That we will see in this next example. So, the examples we have taken is the MAHADA, Maharashtra Housing Area and Development Authority, and they have tied with another private company or the manufacturers of the very innovative building materials, which is called Shirke. So, the combination, the partnership between the Shirke and the MAHADA, they take up all the most of the affordable housing and the housing for the poor in the whole state of the Maharashtra, especially in the Mumbai major cities. So, the materials they use for every component of the house, like foundation, floor slab, columns and beams, wall blocks, finishing and fixture, they take the floor slab to the wall blocks, they take off-site mechanized system, they use the blocks like reinforced concrete block or autoclave aerated concrete block. Similarly, for this they take the lightweight concrete or AAC block, whereas the foundation is done manually and RCC it is done on site. Similarly, the finishing and the fixtures, these are done also on site. So, apart from these stages, floor slabs, column beam and the wall blocks, the foundation and the finishing and fixtures are done on site, and mostly they use a mix of manual and mechanized mode in foundation, in column beam and the wall blocks, whereas the foundation and finishing and fixture, since these three activities are taken place in the site, these are essentially by and large manual process. So, to illustrate the example, we have taken three different different cases, different projects at different location like Mankhad, Pratiksha Nagar and Majgaon in city of Mumbai, and one project will be there for one project will be showing that under construction, another project will be showing that it is completed last few years like 5 years, and another project will be showing which is completed more than 20 years or before. So that we can understand its quality, its durability and its performance as a building, as a housing typology. This is an ongoing project at Mankhad. So, basically it is a redevelopment of transit accommodations done by the MAHADA, So it consists 235 transit units in 5 numbers of G+7 and 60 number of EWS units with steel plus 17 storied high. They have used a FSI of 2.67 and the density is above 3000 per hectare. Those who are coming from a planning or architecture background, you can understand that this density is quite very high in terms of Indian context. Like in major cities, you can see the net density which is calculated in a particular plot is like 1000 or 1500 maximum, but here they could achieve more than 3000. And they have constructed on frame system using prefab beam, column, slab and wall units. I will show how they have constructed. So you can see how the columns, beams are joined here. This is the typical joint of a column. You can see the socket of a column where a particular beam will be placed suitably and fixed suitably. These are the pictures showing the column units. Column units have a hole throughout the column length and it is inserted vertically like this, so that the sockets are available for placing of the beams, and these are the some of the beam element you can see, and over the beam you can see the some of the anchoring element where the slab element will be put and anchored. I will show the picture so that you can understand well. So after placement of the columns and the beams like this, they place the slab element like this. So all the slab elements are independent, treated as a independent prefabricated element. Some are consisting of the RCC element, some are consisting of the cellular concrete block, which is aerated autoclaved concrete element, which is completely manufactured in their own factory of Shirke, and they transport all these materials and put in this manner. After placement of this slab component like this, what they do, they just fill up the slab over a screed concrete of 3 to 4 inch, and they pour the concrete in the holes of the column. So the whole column, beam and the slab become fixed and it becomes more stable, and all the individual components become one isolated strong component as a whole. So after putting the screed concrete over the slab, it becomes a complete strong floor as such, and the whole process of placing columns, beams, slabs and the screed concretes, it takes not more than 8 to 10 days, as I have learned from the field visit which we conducted in last 1 or 2 years in the various sites of the Mahada housing projects. So this floor to floor cycle not more than 8 to 10 days, but at times it can take little more depending on the weather, but technically it should not take 8 to 10 days. So here you can see that how a manual lever is used to fine tuning of the slab component and anchoring the slab component with the anchors and the stirrups left over the beam component. After this fine tuning of the slab component, then the screed concrete will be put and it will be used. You can see the typical pictures of the slab component. Every slab component have the grooves like that, so that after placement of the slab component, it can be acted like the solid one unified component as a slab, and so that it also binds well. It is locked well with each other. Like this. This is the picture of the whole floor, a typical floor. This is how they are lifting any prefabricated component using cranes, and this is a typical picture of a wall component where they are using the AAC block which we call as a lightweight block as a wall component. Also they use the binder, concrete binder, to so that it becomes stronger, it become unified, and these blocks are very lightweight, a single person can carry, and it is also very soft, so that some person can make a groove, or can break it and use it like a common brick, but it is manufactured in such a way, in such a dimension which is standardized dimension, and practically you do not need to cut AAC block too many times, so that you reduce the time requirement for the project construction. Now, in this picture you can see some of the AAC blocks stacked in this site. These are the window blocks. These window blocks are also prefabricated. It is sometimes prefabricated at the factory, sometimes prefabricated at the site and placed like that. And these are the AAC blocks, block walls, how it looks from the outside, and you can see the slab component. From the photograph is taken at the floor level, so that you can understand how the joinery and the arrangement for ceiling fan is kept here. So they use the slabs, blocks and wall panels in this size. You can see that this 600 millimeter, almost 600 millimeter is the standard module size what they use, and for the blocks they use 4 inch, 3 inch or 5 inch or 6 inch module, and it can be the length can be 1 to 4 meter for the slabs, length can be 650 for the blocks, for the wall blocks, and for wall panels it is 1 to 3 meter. So keeping the thickness as 3 to 5 inch and the width as 2 feet, they can go for the 1 to 4 meter and 3 meter. Now let us talk about its strength and durability. The whole structure is designed in such a way that it will give a life cycle of at least 50 years against its durability, its strength against all the possible load component in the building, and they have vetted the design with the help of IIT Bombay, and this is the clause, some of the clauses in the contract between the developer, like developer or the manufacturer and the government housing authority, housing board authority, where you can see that 50 years they have given the guarantee against the durability and the strength for 50 years at least. So 50 years, so that is there, and it is still working for more than 20 years. Some of the project, this particular project was under construction. Now these are the arrangement how they put the conduits for the electrical pipelines. Usually in the normal RCC construction we place the electrical conduits in the floor in the slabs, I mean roof slab, during the casting, but here what they do during the screed concreting, which I discussed little before, over the prefabricated slab component, on the screed concrete they take the conduits like that, and from the screed concrete they take a conduit up to the switch level, switchboard level, but in the conventional construction it is taken from the ceiling. So that is the difference. And another point is, you can see that it is very easily cut by a common even semi skilled labor, so that they can put this place for conduit like this also. This is the exposed conduits. These are some of the pictures showing how the plumbing arrangements are done, the outlets, and some of the drop slabs which is done in situ. Those could be kind of a next stage of improvement, but these are the areas where it is working very nicely as a product, as a design. These are the pictures which is under construction. Now we will see some of the project which is already constructed to appraise or to assess their efficacy against the performance. Now this project, the new Hindu Mills project, is in Majgaon. Now in Mumbai, you know that there are many mills land, so the authority or the government of Maharashtra, they took a policy to use that mill lands for the affordable housing projects. So this is one of the biggest mill land housing called New Hindu Mills. Basically it is a combination of few mill land housing where mill land where they have placed also the original staff of the mills, some transit accommodation and few EWS and LIG population. You can see the adjoining area is full of kind of slum like situation, and this is the housing project which we are discussing. So far 18 housing project in the mill land was already executed, more than 10,000 units till 2014 when we took this study, that time was done. So New Hindu Mill project is the largest and having more than 5,000 units. It is one of the biggest project. So objective of this mill land housing is to utilize the abandoned mill land in the core area of the city in a partnership with the landowner, and sharing of the housing unit for mill land employees and the Mahada for transit as well as EWS unit that I told. So for redevelopment of the other projects, other slums, some of the transit houses will be required. So those transit houses will be accommodated in this project. That was the one of the objective. So you can see the land area was more than 3 hectares, 3.37 hectare, and it was full of G plus 22, 23, 24 storied block having 8 to 12 tenements per floor, and you can see the density. It is very high density and dense project with a compact development which is very high, but with this density at least the housing units are affordable for the poor and the lower middle income group or the lower income group or economical weaker section at this density, otherwise it is not affordable. You can see the layout plan. The layout plan, each building blocks are joined together in such a way so that it makes internal courtyards for enough light ventilation, and you can see the typical building units is repetitive, because we talked last day also that the whole industrialized process or the prefabricated process runs on the standardized design, standardized module. So each housing unit is consisting of standardized module. So we will see one such module in details in the next slide. So this is a standardized module of a typical building block. It consists 12 unit. This is the one unit consisting one multi-purpose room or living room, one bedroom, one WC and one bath area and one kitchenette with some storage area, and this is the common core with staircase and lift block, whereas these are the common lobby to provide the access to each and every unit. So this is the standardized module which they use. Out of this module, the component, this component like the lift shell, lift core and the staircase core, this is done in situ using the RCC basically, and some of the element like bigger columns, these are also RCC, but apart from that most of the elements are done by the prefabricated wall blocks and prefabricated components. This is the finished picture of a finished floor, where you can see the placement of the slab component from bottom. It is painted in colors, and this is the picture of the typical kitchen, where you can see the kitchen slab and the slab component. Only one thing, that since this particular design does not have any balcony as such, so they are using the windows for their day-to-day the storage purpose, or in few cases we have also found that in lobby areas they have used the lobbies for keeping their day-to-day thing. And this is the picture taken from inside, where you can see that the internal arrangement of the slabs and how they have taken the electrical pipelines which is basically exposed. So these are the variation and the outcome of the project. This is the typical unit plan having one living room, one bedroom, kitchen and the WC and one bath. Now only one, this is a very compact design, within this much of 225 square feet of carpet area. So only thing that it could be accommodated another very small balcony, so that people could use it in a multi-purpose way. Other than that, it is a very nice design to accommodate and to generate affordable house within this price and within this much of time. So this is the general views of the project. You can see it is a huge project. This is the view from inside courtyard of the project. Some other views. Now we come to one project which is completed long back, more than 20 years, to see its quality. It is Pratiksha Nagar housing project. You can see the projects like this. Some of the surface cracks is seen during the investigation, during our visit, but those surface cracks are developed due to poor maintenance. Basically it is not a structural crack as such, because structure is durable enough, giving 50 years of the durability and the strength as per the design. So because of the low maintenance, poor maintenance of the projects, it is showing little bit of cracks and some different colors, but otherwise this structure is good enough. So overall inferences from our this particular set of projects is that superstructure has been found safe structurally against weather effects and all kind of load features, like say live load, dead loads and the seismic load, everything. The prefabricated elements like wall, slab blocks have perfectly used right kind of materials consisting weight, cost, energy. However, it needs to be customized unit for the accommodating electrical and plumbing pipe. That's when we discussed in the site, we understood that some of the units could be integrated to have the plumbing and electrical installation, so that during the construction somebody doesn't have to make the grooves separately. Joinery and fittings are the areas where further improvement can be done, but as of now the projects are functioning absolutely in the good condition. It is a very viable and feasible option using frame construction in Indian context, what we discussed. Now let us see a comparative cost of the two projects. To compare, we have taken two other projects so that we can have a comparison. We took Sukha Vrishti, which is basically being developed by Shapurji Palongji in Kolkata as a lower income group housing, and we have taken Subhagriha, which is developed by Tata Housing, and also we have taken New Hindu Mills Housing. We have taken the cost component from their website. So you can see the cost component is much lower than the other conventionally constructed projects, almost 40 to 50, 30 to 40% cost savings are there. And if you see the time in this project Sukha Vrishti and the Shubhagriha, they are taking more than 4 years, but in this case the New Hindu Mills Housing, they have taken 2 to 3 years, because this project is very large project. Otherwise in other projects they have taken 1.5 years or 2 years or even less than that. So median duration of the project is 1.5 year for a mid size, like say 500 units or so, but here the project was so big that 5,000 unit, it took 2 to 3 years. Still it is less than the other conventional projects. So now we come to the present status of India. In India now we have the Pradhan Mantri Awas Yojana by the government of India. Next day we will discuss the Pradhan Mantri Awas Yojana in details, and under the Pradhan Mantri Awas Yojana one technology submission is conceptualized. In this technology submission they have identified total 16 technologies, and IITs and NITs, they are actually basically delivering or offering the research hub, acting as a research hub for the technology submission, because not all the technologies whatever they identified are tested in the field, except 1 or 2 which I showed today. That's why it is under experimentation. So let us summarize the discussion what we had today before I conclude. So today we discussed the some of the example of the industrialized building system in Indian condition. We told that in India after the independence there are a lot of experimentation in material and the systems of the buildings by the government organizations, NGO, but those were basically focused on a particular building component or material. But today we showed another example where a particular agency, government agency is delivering with the partnership with another private developer a complete project using total prefabricated units, using prefabricated columns, beams, slab component and wall block component, so that the project is being completed within 2 years for a mid-size mass housing project, which is comparable to other projects conventionally constructed. The other projects are taking 4 to 5 years, but here they are taking 2 years median, and also the project cost is also less than the other projects. So the learning point in this discussion is that for India the mass housing project using prefabricated building components or prefabricated building technology or industrialized building system is feasible, and probably this is the future. And considering this essence, Government of India, they have conceptualized the technology submission under Pradhan Mantri Awas Yojana, which we discuss tomorrow or next lecture in greater details. So thank you.